Hello. In this video, I'm going to show you guys 4 examples of more advanced questions on finding indefinite integrals. Okay, so we have solved questions about finding indefinite integrals, and they were not too bad, right? Because once we know how to find the derivatives, when we are asked to find integrals, it is just sort of the reversed direction, right? So now, the examples I'm going to show you guys, it's a little bit harder, okay? It's a little bit harder, but the concept and the thinking process is exactly the same. Right, so let's get started. So the first one, they want us to find the indefinite integral of 3x plus 1, the whole thing to the power of 4, with respect to x. So what we can do is we can do this. We can say I'm gonna expand the bracket 3x plus 4, 3x plus 1, 3x plus 1, and I'm just gonna do that 4 times. And I'm gonna expand them, right, one by one. But that will take me a long time. Right, that will take me forever. So instead of doing that, I'm just gonna go ahead and treat this as if this is a box. So something to the power of 4, right? I'm just gonna do that, and I will see what happens, right? And I will deal with it. Okay, so if I treat that as a black box to the power of 4, right? Then the derivative, so what do I differentiate to get that? It will be the box to the power of 5, right? So because when I reduce the power by 1, I get the power of 4. But since the 5 will have to go to the front, then I need to take care of it. By having a 1 over 5 in the front. Right, so when the 5 goes down, it gets cancelled out. Right. So what's in the box? The box is just 3x plus 1. So let me erase the box outside. So it will be 1 over 5 times 3x plus 1, the whole thing to the power of 5. Okay, so let's see if that's true. So when my y is equal to 1 over 5, 3x plus 1 to the power of 5. And when I differentiate that, when I find the derivative, I get 1 over 5, multiply the 5 goes to the front, multiply 5, multiplied by 3x plus 1. Oops. 3x plus 1 to the power of 4. Am I done? Not yet, right? Because I need to take care of the 3x plus 1 inside as well. So if I differentiate the inside, I'll get a 3. So the 5 and the 5 cuts out, that's perfect. So we get this 3x plus 1 to the power of 4. And this is 3, multiplied by 3, so this is 3, which I don't want that 3, right? So I need to take care of that, right? So how can I remove this 3? By putting a 1 over 3 in the front, right? Just if I have a 1 over 3, then that 1 over 3, this 1 over 3 is going to take care of the 3 that comes out later. Right, so this plus c, don't forget the plus c. So the 1 over 3 and the 1 over 5, I can combine them. I get 1 over 15. 3x plus 1 to the power of 5 plus c. So now let's check if what I have over here, the indefinite integral that I have here, is it correct? So say if my y is equal to 1 over 15, 3x plus 1 to the power of 5 plus c. If I find the derivative, so I'll get 1 over 15. The 5 go to the front, I'll have multiply 5, multiplied by the 3x plus 1, and the power drop by 1, so I get 4. Now if I differentiate the inside, I get a 3, right? So this becomes 1 over 15. The 5 and the 3, that becomes 15. And then we have 3x plus 1 to the power of 4. 15 and 15 cancels out. I get 3x plus 1 to the power of 4, which is what I have over here. Okay, So my indefinite integral is good. That is good. Okay? So you can see that the thinking process is pretty much the same. And what we're doing here is just try to take care of whatever shows up by in this case by adding this 1/3 fraction, right? Similarly, it's a similar concept when we put that 1/5 there, right? Pretty much the same concept. Okay. Let me erase the part where I checked what I was just checking my answers. Let me erase that. Now I want you guys to look at example B. For example B, what are we asked to do? We're asked to find the indefinite integral of e to the power of 2x plus 5 with respect to x. So in this case, I have an exponential function, and inside there's a 2x plus 5. But before I get scared by all this, let's just think about this. What do I differentiate to get that? What do I differentiate to get that? It has to be itself, right? It has to be itself. Because when I differentiate e to the power of anything, that'll get itself, right? So my answer, for now, my answer is that. So let's see. When my y is equal to e to the power of 2x plus 5, and if I differentiate that, I get e to the power of 2x plus 5. But is that it? No, right? Well, I need to take care of this linear part. So multiplied by, if I differentiate that, I get 2. So I get 2e to the power of 2x plus 5. Right? So that's my derivative. So what I have over here, that's not good enough, because if I differentiate this part, right, I'll get that. Right? So I need to, which is with an extra of 2 in the front. So how can I take care of the 2? Having a half in the front, and that's it. Okay? Like I said, similar concept. We're just making sure that we take care of the stuff that it's kind of taking care of the byproduct. In this case, the byproduct is 2. So how do I take care of that? I took care of it by having this half in the front. All right. Let's take a look at another example. Right. So 2 more. In this case, I have 3 multiply that, so I can take the 3 to the front. Right. That's just a 3, just a coefficient. So 1/4x minus 2, with respect to x. Right. So let's think about this. What do I differentiate so I will get this? I'll get a 1/. Right? What do I differentiate so that I will get 1/, something? I hope your answer is ln, right? Your ln x. Because when you differentiate ln x, so if y is equal to ln x, dy dx gives us 1/x, right? So instead of ln x, I'm going to differentiate ln of 4x minus 2. Does that make sense? Right? So if my y is equal to ln of 4x minus 2, if I differentiate that, I'll get 1/4x minus 2. And then I'm going to take care of the inside, which is multiplied by 4. Right? So I'll get 4/4x minus 2. Right? So I need to take care of the 4, because right now I don't want that. Right? I don't want right now I only want 1/4x minus 2. I don't want the 4. So how do I take care of the 4? Again, by having a fraction. Right? So I can multiply the 3 with my 1/4. I get 3/4 ln 4x minus 2. Don't forget your plus c, right? Plus c. All right. Okay, last one. So this, for me to do that, let's think about this. Now, can I maybe I can use my ln, right? Maybe I can use my ln, but I have this power of 4, so that's kind of annoying. So let me try to rewrite that. So maybe if I change this to 6x plus 3 to the power of -4 with respect to x. Maybe that helps me a little bit. And I think that it's actually easier that way. Why? Because I can think of this as a box. This can be my box. Right? So I have something to the power of -4. And all I have to worry about now is what do I differentiate to get that? So obviously it's going to be the box, right? The box to the power of -3, right? Because when I differentiate, the power has to be -1. So if I go in the opposite direction, I have to add 1, so I get that. What's in the box? The box is 6x plus 3. So let me erase the box for now. All right, so 6x plus 3 to the power of -3. Am I done? Let's see. So if my y is equal to 6x plus 3 to the power of -3. If I dy dx, I bring the -3 to the front, -3, and the 6x plus 3, I would drop the power by 1, so I get -4, which is what I have over here. That's good. And this part is good, but this is a byproduct, right? That's a byproduct, so I need to take care of that. But when I find the derivative, am I done? Not yet, right? Because I need to take care of the linear function, this 6x plus 3 inside. So if I differentiate that, I get 6. So in fact, my byproduct is -18 plus -18 multiplied by 6x plus 3 to the power of -4. This is my byproduct, so I need to take care of it, right? So I'm going to take care of it by multiplying a -1 over 18. So I can simplify this. This will become -1 over 18, just to kind of clean it up, right, to look better. 6x plus 3 to the power of -3 plus c. All right. Sorry about the squishing in I'm running out of space over here. But I hope you guys understand what I'm doing. We are just thinking about what's the byproduct and figuring out ways to take care of them. Okay? Feel free to ask me any questions in class, and I'll see you guys in the next video. Bye-bye.